Hi, hello everyone. Welcome to SK Academy of Mathematics. Today, let us learn how to solve the problem on divergence and curl of the vector field, where they have given the vector field f with respect to gradient x y cube z square. Find a divergence vector f and curl vector f at the point 1 comma minus 1 comma 1. How to find divergence vector f and how to find curl vector f? Now let us see. First, let us find the divergence vector f. Okay, first represent the given, that is given vector f which is equal to gradient of x y cube z square. Done? Yes. Now first we need to find vector f. What do you mean by vector f? That is, it should vector f defines with respect to the direction, that is with respect to I, j, k. Okay, so what we are going to do, we are going to find gradient phi. What is phi? Phi represent the given function, that is phi which is equal to x y cube z square. We need to find gradient phi. What is our? We know that gradient phi which is equal to x y cube z square. Done? X y cube z. Okay, sorry, gradient phi. So not this is phi, but what is gradient phi? We have, sorry, gradient phi we have dou phi by dou x I cap plus dou phi by dou y j cap plus dou phi by dou z k cap. Done? Yes. Now differentiate the function phi with respect to x, y and z. Now let us find gradient phi. Gradient phi which is equal to dou by dou x into x y cube z square. Next plus dou by dou y into what we have, x y cube z square plus this is with respect to I cap, this is with respect to j cap, dou by dou z into x y cube z square with respect to k cap. Done. Now differentiate this term with respect to x. See what we have in this term, we have x. Yes, we have x. Just write down y cube z square as constant. Differentiation of x is 1. That's it. With respect to I cap. Completed? Yes. Now let us go with respect to y. What is y? We have y. Yes. X and z square remains constant. X and z square remains constant. Differentiation of y cube 3y square. Done? Yes. With respect to direction j cap. Next, with respect to z, x y cube remains constant. Now differentiation of z square, we have 2z into k cap. Done. Now gradient phi which is equal to y cube z square I cap plus 3x y square z square j cap plus 2x y cube z k cap. Just we have written in the order form, that's it, nothing more. Okay, this is our gradient phi. Now what they have asked to find, see, this is our vector f which is equal to gradient phi. Now vector f is defined with respect to the direction, that is y cube z square I cap plus 3x y square z square j cap plus 2x y cube z k cap. This is our vector f. Got the point? Yes. Now we are going to find divergence vector f. See, consider divergence vector f is given by dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. What is f1, f2, f3? This is called as f1, this we call it as f2, and this we call it as f3. Now let us represent, that is where f1 which is equal to y cube z square, comma f2 which is equal to 3x y square z square, comma f3 which is equal to 2x y cube z. What the point? f1, f2, f3? Yes. Now just simplifying divergence vector f. That is divergence vector f which is equal to dou by dou x into f1. What is f1? Y cube z square plus dou by dou y of f2 we have 3x y square z square plus dou by dou z of 2x y cube z. Now differentiate f1 with respect to x, f2 with respect to y, f3 with respect to z. Simple. See, divergence vector f. See, we have any variable with respect to x? No. If there is no variable with respect to differentiating term, that is with respect to x, this term becomes 0. How it becomes 0? Y cube z square will be constant. Okay. If there is no term with respect to x, there will be 1. Differentiation of 1 with respect to x is, that is differentiation of constant term with respect to any variable is 0. 0 into anything, this will be 0 plus, now we have y square, yes we have y square, that is 3x z square remains constant, differentiation of y square 2y plus, now differentiating z, we have z, yes we have z, 2xy cube remains constant, 2xy cube remains constant, differentiation of z with respect to z is 1. Got the point? Yes. Divergence vector f which is equal to 3 2s are 6 x y z square plus 2x y cube. This is our divergence vector f. Now what we are going to do? We are going to apply the points at the point 1 comma minus 1 comma 1, where x equal to 1, y equal to minus 1, z equal to 1. Got the point? Now divergence vector f which is equal to 6 into 1, y we have minus 1, z we have 1 square. Similarly, next we have 2 into 1, y cube we have minus 1 the whole cube. That is divergence vector f which is equal to 1 square 1, 6 into 1 6, 6 into minus 1 minus 6, minus 6 into 1 minus 6, minus 1 the whole cube minus 1, 2 into minus 1 minus 2. Divergence vector f which is equal to minus 8. This is the value of divergence vector f. Now we are going to find the value of curl vector f. What is curl f vector? Curl vector f is represented by I, j, k, dou by dou x, dou by dou y, dou by dou z, f1, f2, f3. Determinant matrix multiplication. Okay, consider. The next step is consider. Okay, done. Now curl vector f which is equal to I, j, k, dou by dou x, dou by dou y, dou by dou z. What is f1? F1 we have Copy down that only, that is y cube z square. Next, F2 we have 3x y square z square. Next we have 2x y cube z. Now do the determinant matrix multiplication, that is curl vector f which is equal to I into dou by dou y into 2x y cube z. Please be careful while representing. Now dou by dou z minus dou by dou z into 3x y square z square. Done. This is with respect to I. Next comes minus j. Next dou by dou x into 2x y cube z. Okay, now close the bracket, minus dou by dou z into y cube z square. Done? Yes. Next, the last k into, that is dou by dou x into 3x y square z square. Next, minus dou by dou y into y cube z square. Done? Yes. Now differentiating term by term, curl vector f which is equal to I into, see we have y, yes we have y, 2xz remains constant, 2xz remains constant, differentiation of y cube with respect to y we have 3y square. Got the point? Minus, now differentiate z. In this term I need to differentiate with respect to z. I have z, yes, 3xy square remains constant, 3xy square remains constant, differentiation of z square we have 2z. Completed with respect to y? Yes. Next, minus j into, since I have x, 2y cube z remains constant, differentiation of x with respect to x is 1, minus, now I need to differentiate with respect to z. So what I am going to do, y cube remains constant, differentiation of z square 2z. Last, k plus k into, now I need to differentiate with respect to x, so 3y square z square remains constant into differentiation of x with respect to x is 1, minus, now I need to differentiate with respect to y, I have y cube, z square remains constant into differentiation of y cube 3y square. See, curl vector f which is equal to I into 3 2s are 6 x y square z minus 3 2s are 6 x y square z minus j into, see, 2 y cube z minus 2 y cube z plus k into 3 y square z square minus 3 y square z square. See, this get cancelled, this get cancelled, this and this get cancelled. Curl vector f equal to 0. If curl vector f is equal to 0, we call it as the given vector field is irrotational. I hope you have understood this problem with respect to solving divergence and curl of the given vector field, where we need to find first gradient phi, and considering that gradient phi we are going to represent with respect to vector f. Considering this vector f, I am going to represent divergence vector f. Solve and differentiate and apply the points with respect to 1, -1, 1, and you will get the value -8. With this complete divergence vector f. And next, curl vector f. This is the standard formula of representing curl vector f. Just a determinant matrix multiplication, simplify, you will get everything, values get cancelled, curl vector f will be equal to 0. If curl vector f is equal to 0, then we call it as the given vector field is irrotational. I hope you have understood this problem. For more videos, please do like, share and subscribe. See you in the next video. Thank you.